You can pull up a crystal clear photo of Mars on your phone. Canyons, dust, ice. It looks almost reachable. Then you remember the truth underneath the picture. In the closest years, Mars is still tens of millions of kilometers away. In the farthest years, it can sit more than 200 million. That gap is why every Mars plan feels harder than the posters suggest. This is Path to Mars on the Quantum Files. Episode 1 is about the simplest problem with the biggest consequences. Why the trip itself still makes everything else expensive, slow, and risky. Getting people to Mars is not one invention. It is a stack of hard jobs that all have to work. You need launch chances that only open every so often. Ships that can keep a crew alive for months. A landing that puts heavy gear down without destroying it. Power that survives dust and long, cold nights. Water and rocket fuel made on Mars. So Earth is not shipping every kilogram forever. Radios that still help when help takes minutes to arrive. Medical care that cannot wait for an ambulance from another planet. And a way home, or a safe way to wait until the next ship can come. This series will walk those problems one at a time. Mars is possible. Possible is not the same as ready. Tonight we stay on distance because distance makes every other problem heavier. Earth and Mars do not line up on our calendar. The best low-fuel trip chances come around every 26 months. Miss one, and you do not try again next week. You wait for the planets to swing back into a useful position. That waiting shapes everything. How big the crew can be. How much spare food and oxygen you dare to pack. How patient a country or company has to be when a program slips. Look at the clock on screen. Those green windows are rare doors, not everyday flights. The moon is close enough that you can often try again soon. Mars runs on a slower heartbeat. Patience is not a personality trait here. It is part of the engineering. On a classic fuel-saving path, the cruise can last about 6 to 9 months. Faster routes exist on paper. They usually need more energy, heavier ships, or technology that has not been proven yet at Mars scale. So the default trip is long. Long means radiation builds up. Long means the body adapts to floating before anyone stands in Martian gravity. Long means spare parts, medical kits, and mental stamina have to last through quiet months with Earth as a tiny blue memory. And long means bailout options shrink. Past a certain point, you are not turning around for milk. The curved path on screen looks elegant. It is also a commitment. Distance hits your wallet through mass. Every kilogram launched from Earth costs rockets, fuel, and risk. On a Mars trip, that kilogram also has to survive months of cruise, a dive through thin air, and a landing that is still one of the hardest tricks in spaceflight. That is why engineers obsess over making stuff on Mars. Oxygen, water, fuel cooked from local materials. If that works, Earth ships less, and the whole plan gets saner. If it fails, Earth remains the only warehouse, and a warehouse that far away is fragile. Bigger landers and better power systems chase the same idea. Not romance, shipping less. Even light has to travel. A one-way radio delay to Mars can run from about 4 minutes to more than 20, depending on where the planets sit. A back-and-forth chat can take longer than lunch. So Earth cannot remote control a medical emergency in real time. A stuck rover, a leaking habitat, or a landing surprise has to be handled by people and systems already on the trip. Better laser links can carry more data. They do not change the speed of light. Autonomy is not a buzzword here. It is how you run a delayed planet. Hold one plain sentence. Distance turns urgent decisions into delayed letters. People ask whether better artificial intelligence could compress Mars timelines. Honest answer, maybe in places. Software can help design paths, spot failures earlier, and tighten the loop between testing and flight. It cannot move Mars closer. It cannot make a kilogram free. It cannot erase orbital geometry. Where intelligence helps most is cutting waste and catching problems before metal flies. Where it helps least is pretending physics is optional. On the Quantum Files, we keep both ideas in view. Room for progress, no magic. Put the pieces together. Rare launch chances, months of cruise, heavy shipping costs, radio delays measured in minutes. None of that means quit. It means the first hard truth of Path to Mars is distance itself. The Moon is practice range. Mars is the longer campaign. Next episodes will open the next doors, landing heavy cargo, making fuel on the surface, surviving dust and radiation, building a home that is more than a temporary tent. For now, remember the cold open. Close enough to photograph, far enough to hurt. That tension is the path. This is Path to Mars on the Quantum Files. Subscribe if you want the next chapter when it lands.